So let's take a look at these two numbering systems now in a little bit greater depth. We'll start with the one that you're most familiar with, which is the decimal system, or base 10. It's called base 10 because it's based on multiples of the number 10, and the entire numeric system has only 10 digits, 0 through 9. When we write out a number like 246, what we're really doing is organizing these numbers into columns, and each column is assigned a value of a multiple of 10. Those multiples of 10 are the powers of 10. We start with 10 to the 0 power in the right-hand column. We continue into the second column with 10 to the first power, and that's followed by 10 to the second power. And if we continued on, we'd have 10 to the third power, then 10 to the fourth power, etc., etc. In the next row, we translate the powers of 10 into their corresponding numeric values. For instance, 10 to the 0 power is the ones column. 10 to the first power is the tens column. And 10 squared is the 100s column. So the number 246 really means we want to take the number 2 and multiply it by 100. Add to that 4 times 10, then 6 times 1. Add up those three numbers, and that's how we get the total of 246. So now, let's apply these same principles to the binary numbering system. The binary system is called base 2 because it is based on multiples of the powers of the number 2. And there are only 2 digits in that numeric system, 0 and 1. This is a representation of a binary number, 1010. And again, it's being organized into columns. This time, the columns are represented by the powers of 2. Just like we did with our decimal numbering system, we start with the 0 power in the right-hand column, so in binary, we begin with 2 to the 0 power. Then we have 2 to the first power, then 2 squared, followed by 2 cubed, and if we continued on, we'd have 2 to the fourth power, 2 to the fifth power, etc., etc. In the next row, we indicate the decimal values of each of those powers of 2. 2 to the 0 power is decimal value 1. 2 to the first power is decimal value 2. 2 squared is decimal 4, and 2 cubed is decimal 8. So in this example of 1010, we are saying that we want to multiply the first one on the left by the decimal value 8, then multiply the first 0 by decimal 4, then multiply the second one by decimal 2, and then the last digit, the 0, by decimal 1. Add up those results, and we get the decimal value of 10. This means that the binary value of 1010 is equal to the decimal value of 10. Later on in this tutorial, we'll demonstrate how you will use this knowledge to convert an 8-bit, meaning 8-column, binary number into its equivalent decimal value, and how to convert a decimal value into its 8-bit or 8-column binary value.